It has come to my attention that I did not include example 3. I don't know how I didn't include example 3 in the notes from section 6.3. Basically, you need to find one of the functions that you're given that's easier to solve for t. We chose the second one, the y equation, and we chose the y equation. We solved it by dividing by 3. And then we said, hey, let's go plug that into the other one. So you're basically just doing substitution. And so we substituted and did some simplifying. You'll notice I put it in a blue box because technically you have eliminated the parameter. Okay? I do some fancy stuff here with, solving it for y because math teachers really love to do that all the time. So we added 2, multiplied by 9, took a square root. So we had a perfect square trapped inside. Don't forget your plus and minus. Now, what this does illustrate, though, is if you wanted to graph this in regular function notation, you'd have to do it on a graphing calculator with 2 separate equations. But that is not what you'd have to do. That is not what you'd have to do in parametric mode. If you want to graph this thing in parametric mode, you've got an equation for x and an equation for y. You just plug them in, and it will, and as long as your t is set, like your t min and t max can be set, I don't know, you can make them like -10 to +10 just to be careful, I don't know. But then you should get a shape that looks like this. So sometimes the parametric graphing is easier. Eliminating the parameter shouldn't be that much of a difficulty for you because you're just substituting. And like I said, technically, that would be good enough if you have eliminated the variable t, I should say. Okay, that's enough for example 3.